So we'll write it here. All right. Oh. Well, I'm just on the wrong end, but we're still good.
That computer can do Windows as well.
Yeah, but that's this machine. I don't. All right, we're good. All right. So homework was to solve the isPrime problem, right? Write a function that takes in a number, and it should return true if that number is a prime number, and false if it's not a prime number. Where prime numbers are numbers that are only divisible by themselves and 1. All right. And I said for, at least I think I said that you didn't have to handle the special case because like 0 is, 0 is not prime? 1 is not prime. Yeah, so those are kind of two special. Did I say you didn't have to handle those?
No, you didn't.
Okay, if you handled them, it's fine. If you didn't handle them, that's fine. I'm going to write it not handling them first so we can focus on the loop aspect. It's just 2 extra if statements at the beginning, or one if statement. If the number is a 0 or it's a 1, return false. Else do your loop. Okay. Shut up. Don't forget, student get together is next. What's today? Thursday? Next Wednesday. Next Wednesday, 11 a.m. in here. So unless you have a class, I strongly encourage everybody to show up. Free food, and they also give prizes like trivia and stuff. And it's like good prizes. Like we've given out PlayStation VRs before. I mean, like legit prizes, not like, you know, junky bouncy balls and stuff. But you got to show up and participate and do the quiz stuff. Yeah, so the computer science department does that every semester, where we try to get as many students together as possible to, you know, for all of you to get to know each other, and also the upperclassmen, so who you can then go to and you know, get help with homework. And I know some of you are taking advantage of like the CS club's study nights. Like just had one last night. I think they meet in here, don't they? You know, so the people who run that are, yeah, like, I mean, Emily Sear, she could have done your homework in here in a minute. So, I mean, she would have been somebody who would have been a good person to bring your group to and say, hey, can you help explain this? You know, so take advantage of those things rather than just, not that I mean, ultimately the goal is that you learn it. So just having somebody else do your homework for you isn't going to get you where you need to be. But having those resources between classes is going to be beneficial. So I encourage you to work in groups so you're all struggling through it together. And then also go to other resources. You can come to me through Slack or whatever, but also get to know the other students in the program, because many of them are very willing to help. Yeah, go ahead. Which one? I think I got it, but I wasn't listening. Isn't that from what? Was that the Lego movie? I think from a couple of years ago. Which one are you asking about? I talked about 2 separate things. Both of them. First one is student get together, computer science get together is next Wednesday at 11 a.m. in here. Free lunch, good prizes. And then the you'll have to watch Slack for when they have the study groups, but like I don't know, is it every single Wednesday?
Yeah.
Every single Wednesday there's something.
And this
But
this weekend, this coming one is going to be Tech Talk.
yes, yeah, next week I think, is it SkyGen? Yeah, Mike Gardapi from SkyGen is giving the next Tech Talk, so that's next Wednesday.
Yeah.
6 p.m. over in the business building, I'm assuming, Makerspace.
Maybe this space.
I think it's in the I think it's down by the business building. Yeah. So Mike, that's definitely show up to that. That's 6 p.m. next Wednesday. I think it's probably in the Collaboratorium is the name of the thing. That's over by where all the 3D printers are over in the business building. SkyGen, we have 4 interns with them right now, and then we have 3 or 4 students who graduated over the last couple of years who work full-time for them. So that's definitely a relationship to make. Go ahead. I might be lying. 12 to 1 sounds right. Yeah, thank you. Yeah, it makes sense because I have class from I have class 11 to 11:50. It's right after my class. Thank you. I was testing you and you passed. Yeah. Mask again, man. No worries. All right. So any other questions before we dive into the homework? So do take advantage of all those things. I mean, I really appreciate the students when you're working on your homework assignments, when you do email me asking for help and things like that. But the impression I get from several of you that you're doing this solo, that's going to be a tough mountain to climb. Not that you can't do it. And I know some people, your schedules don't permit you to necessarily get together with groups, but now with Zoom and stuff like that, I strongly encourage you to, get together in some study groups, and because those groups will last for all 4 years. We got seniors who are still working with the same group of people they started with in their 200 class, kind of learning this stuff together. The more you can, and if you're one of the stronger people, when you're teaching other folks, you get better. And when you're a student who's currently struggling, a lot of times it helps you to learn by hearing it from somebody else who is even partially struggling, but maybe not struggling as much as you, rather than just seeing me do it. Okay, so take advantage of all those resources, because at the end of the day, the goal is for you to learn the stuff, right? All right. So let's go here. Save this. Yeah, I think I just did it in the scratch pad thing here, right? All right, so let me get rid of some of this. All right, so our goal here is we want to create a function. We talked about functions last time, so we want to write a function that ultimately is going to return a Boolean. And is it all lowercase or all uppercase? Whatever. It's lowercase. We'll see in a second. Okay, so maybe this guy is called isPrime. So that's going to be the name of our ability. Remember, a function is a chunk of code that we write once that we can call multiple times. So the idea is that we can pass it different inputs, and it gives us potentially a different answer based on us writing it generically. Okay, so we're creating an ability that we can choose to call upon later on. So this guy's going to return a Boolean, true or false. We're going to call him isPrime, and he needs an integer in order to work. We can call it n, we can call it the number if you want, whatever you want to call that integer. All right, now I'm going to go ahead and get us into that, into practice of prototyping our functions at the top and then writing them later on, like we talked about last time. So I'll just put a semicolon there, and I'll copy this top line, and we'll go below main, because I said last time I like to have main up near the top. But in this case, if you just wrote the whole function up here before main, it would have worked fine. Okay, let me get rid of this guy. All right, so what is a prime number? A prime number is a number that is only evenly divisible by itself and 1. Okay, that means how can we detect that something is not prime? A number is not prime if we find any number between 2 and the number itself minus 1 that evenly divides it, right? If we check that number against all of those numbers, 2 to the number minus 1, and any one of them evenly divides it, we can immediately stop. Not a prime number. We found at least one other number between 1 and the number minus 1 that evenly divides it. All right, so in order to determine whether the number is prime, we know it's evenly divisible by 1. All numbers are evenly divisible by 1. We know it's evenly divisible by itself. All numbers are evenly divisible by themselves. We're checking everything in between. So we're going to go through, we're going to write a loop. For int I is equal to 2. I is less than the number, up to but not including the number. I is equal to I plus 1. All right, so this loop is going to take I on a voyage between all the numbers between 2 and whatever number was passed in, minus 1.
Can you divide that by 2?
If you want to be more efficient, yes, but let's keep it as simple as possible. We're going to check every single number between 2 and the number minus 1, potentially. Each time through, we want to ask a question. We're going to say, if the number I'm wondering if it is prime, if that number, when divided by the current value of I is 2, then it's 3, then it's 4, then it's 5. So if the number I'm checking to see if it's prime, when I divide it by the current value of I that this loop is taking me through, if I evenly divided it, that means I found a number, I, other than 1 and the number itself, some other value between 2 and the number minus 1. I found a number that divides the number evenly, which means this guy is not prime. Prime numbers are only evenly divisible by themselves in 1. I found another number that evenly divides it, not prime. Now remind me, what does return do? Go ahead. Okay. Potentially returns a value. Okay, we had a slide on this. This guy right here, return, makes a function immediately end. I don't care if I'm only my third pass through a for loop that's going to go through 10,000 times. As soon as I get inside this if statement, if I find even one number that breaks the rules of being prime, I'm killing off my function. It's not prime, my function ends with a return. And because I've advertised that this function will return a Boolean value, I am now allowed to return a value from it. So I'll return false. Now, if I don't get into that if statement, that means that at the very least, the current value of I did not evenly divide it. I don't necessarily know that it's prime. I just know that I passed one more test, right? Maybe it's not evenly divisible by 2. Well, that doesn't mean it's prime. It means that I need to check 3 and 4 and 5 and 6. And if I get all the way up to the number itself, and I'm still alive, I still haven't hit this line of code, that means I've broken out of this for loop. This for loop has had a natural end, right? So if I'm still kicking right here, if I'm still in the function after that for loop, that means I have checked every single number between 2 and the number minus 1 and didn't find a single one of those numbers that evenly divided the number. So if that's the case, I can return true. It's a prime number. Okay. So we can go ahead and test this. So I'll do cout is prime of 4. 4 should not be a prime number because it's evenly divisible by 2. So there's my false. 0 is false. 1 is true, or non-zero is true. What about 5? 5 a prime number? Yep. There's our 1. This guy's a prime number. 6 not prime, 7's prime, so on and so forth. All right. So I could go and write a loop here for int I is equal to 0, I is less than, let's say, 20. And I'll go ahead and call my function. I'll go ahead and print out we'll see whether or not it's prime. So this is going to be all the numbers between 0 and 19. I'm going to print out the number and then the result of calling is prime on that value. And remember, we're not handling 0 and 1 properly yet. So right now we have 0 and 1 both flagged as being prime numbers, but we decided those are actually special cases and they're not prime, right? So we'll come back to that here in a second. And if you didn't handle that in your homework, that's okay. But we see 2 to 19. 2 is prime, 3 is prime, 4 is not, 5 is prime, 6 is not, 7 is prime, 8, 9, 10, not, so on and so forth.
You could take that for loop and put y is equal to 2.
Well, yeah, I mean, this loop, this isn't, I mean, this loop just says do something some number of times.
Yeah.
I could start this off at 213 and go all the way up to 2091 or 2091
No, I'm saying
or 200.
that 1 and 2.
Yeah, but I mean, that doesn't change my logic at all. This is just what I'm testing. These are the numbers that I'm testing. Okay, loops solve a problem. What does a for loop lend itself to? It lends itself towards counting problems. Doesn't matter what you start with, doesn't matter what you end with, as long as it's numbers that you wanted to go between. If I wanted to start with 213 and I wanted to go up to 291 or 290 in this case, since I'm going less than, I'd write this loop. And how I'm using my value I, in this case, I happen to be passing it into a function. That's great. So now that's the input to my function, but I don't have to do that. I can write a loop that just does something like our last assignment just said, hey, I want to do something 100 times. I didn't use the value of I in the last homework assignment. I just did something 100 times. And I used I to count. And what did I do? I printed out the numbers between 0 and 9 to the screen 100 times. That was the last homework assignment, right? So this guy is just the tool. This is that idea we talked about last time where we're looking at the fundamental skills. We know how to loop. We know how to ask questions. We know how to remember stuff. So I'm giving you all these Legos. So you have these Legos laying in front of you, and now I'm saying, go and solve the problem. A little puzzle that I've given you for your homework assignment using these Legos. And the more often you do that, the more you put the reps in, the better you'll get at solving those problems. Okay? Because right now you're a beginning programmer, you're not going to be skilled at solving those problems very quickly. You're going to sit there and grapple with it, and you're going to, send me an email or ask your friends or whatever, and you say, I don't understand why it's working. And what you have there is likely nonsensical. But that's okay, because you have to write all those nonsensical stuff and understand why it's nonsensical before you can understand the right way of doing it on your own. Got to put in those reps. You got to fail over and over and over again until you finally start getting it right. All right, so spending 4 or 5 hours on this, I know it sucks. I know it's taking longer than some of your other assignments and other classes might take. It's the nature of the beast, and it'll pay off in your bank accounts later on. Okay, that's the punchline. I told you day one, programming is just not one of those things you can cram for. You got to put in those reps, and I promise you it'll pay off later. All right, so if we want to go ahead and just finish up our catch-all on this, because 0 and 1 are special cases here, we can write a little if statement before we start checking against all the prime values or all the possible failure points. We could just say if the number is equivalent to 0 or the number is equivalent to 1. If either of those things are true, return false. So I'll just ask an extra question before I get started with this stuff. If I'm looking at a 0 or a 1, not a prime, false. And again, what does return do? Return makes the function immediately end. I'll never get to this line if this function died right here. So now I can say 0 to 20, and we'll get the correct answers for our 0 and 1. 0 and 1 are not prime. Go ahead.
Okay, so 2 things. So int the number, unless I missed this, how is it actually defined? Because the number isn't
Right here.
okay, so
This is me writing an ability called isPrime that expects me to pass it an integer. This is me actually passing it an integer. I'm passing it a 0, then a 1, then a 2, then a 3, then a 4. This is me calling this function. This is me defining that function.
okay. Yeah.
So each time through the number, if I just think about this loop, the first time through, I call isPrime, I pass in a 0 for I, the number for that particular call will be equal to 0. The next time through, I is 1. So for this next call to isPrime, the number is equal to 1. Then 2, then 3, then 4, so on and so forth. Make sense? All right, and you said just more stuff?
Yeah.
Yeah.
My other question is, when I was trying to do it last night, and I just did like return false, it just wouldn't bring back anything at all. But like for you have 0.
Because I'm purposely printing it. Yeah, so if I just do this, let's take out the C outs. If I call that function 20 times like I'm doing here, I'm getting an answer. This will be true or false every single time, but I'm not doing anything with that answer. So the output of this program will be nothing, even though I'm calling that function 20 times. I'm just not, because what happens here is when I return false or true or false here, what's ultimately happening is some value is firing out of the back of this thing, okay? And if I don't do something with it, I kind of think of it like a pitcher, catcher, or whatever. Realistically, what's actually happening is this dude is boiling down to a value, but I think it's fair enough for us to say some value is firing out of the back here. And right now, I'm doing nothing with that value. I'm not printing it. I'm not catching it into a variable to do something with it later. I'm not doing anything, which is why I'm not getting any output. My program is still calling this function 20 times. It's happening. I promise you it's calling that function 20 times. I'm just not choosing to do anything with the result. Make some sense? You have another thing?
No,
Okay, good. Back.
I didn't know that
Mm-hmm. We see that it is an integer, right? Okay. It actually will be a Boolean in a language like this. In a newer language, though, like Java, it protects the Boolean type. So you'd want to get used to treating Booleans as trues and falses, even though we see they're actually 0s and 1s, because C++ exposes us to how it's the underlying way it's being stored, where a newer language would not. Yeah. So, I mean, it'll be a 0 in the homework, obviously, but the yeah. No, the important thing on this assignment is getting practice with this loop stuff. Right? And keep in mind, I mean, I want us to keep coming back to this idea. Remember day 1 of class. I said, how do human beings solve problems? Remember stuff, ask questions, repetition. Every single program we write is going to be using those tools. Okay? And I'll make another statement today. Every hard program is made up of a bunch of easy parts. There is nothing earth-shattering about that line right there, right? That line is, I mean, we're not hiding under the desks because of that line. Similarly, there's nothing earth-shattering about that line. Or this line. Or this line. But putting them together in the right order, in the right context, all that stuff, that's what's difficult for us right now. Make some sense? All right, let's go here and then back to you. Go ahead. Yeah, that's fine. Yeah, all I care about is the logic. I mean, if your output is just random crap, I don't care. I'm looking at code. I want to see you grow as a programmer with the logic. If you wanted to write a whole sentence, this number is prime, this number is not prime, it's fine. Go ahead.
So when we have like the function type defined,
when you're calling this guy the function type. Yeah, so I usually would call this the return value, but it's fine. I just want to make sure we're talking about the same thing.
So return value is an integer, return value Boolean is
Which you now know is an integer.
Right.
Yeah.
So if then you use the void return type, is that the only way you can use the without sending the value?
No.
Because
It'll yell at you. You can use return whenever you want, but functionally, I think the answer to your question is yes, because you're about to say that when I used return with a without a void type there, it screamed at me because it said, you told me you were going to return a value and you didn't. Okay, so the idea here is he wants to know if I make this void like that. Can I do that? The answer is yes. But if I make this Boolean and I just say return, it's not going to work. But the reason for that is you've promised that you'll return a Boolean. And right here, you have failed in fulfilling that promise. You returned, but you didn't return a value. Well, if you return 0 or 1, it'll be fine.
Oh, no, I meant like up top, if you put like, is prime is equal to 0, or is prime.
No, don't expand it outside of this. Just look at what we have here. I have made a promise to the compiler. I have said, whenever I call isPrime, expect me to spit out a Boolean. That is a promise I'm making to the compiler. Right here, I have not fulfilled my promise. Return made this function end, but I did not spit out a value. I have lied to C++, and it's not going to be happy about it. Okay, and you said that in here it didn't actually give you a warning or anything, it just didn't work?
Well, yes, I use the program.
Yeah, okay. Okay, yeah, so it gave you an error. Yeah, which is correct. Java will do the same thing. Java will say, look, you told me you're going to return a Boolean, and then you didn't. You're a liar. You return something or you reconsider what you're putting here. One of those two. Okay, don't do this bait and switch stuff. Okay, that makes sense? Whatever we put here, that is us advertising what we intend to do from this function. We better live up to that. Go ahead.
So this way you could run
Okay, so instead of you having zeros and ones, you want to say, how do I say true or false? Yeah, I got you. So what we would maybe do is we would maybe up here say the number, I'll just be kind of verbose with this, I is find it right here. If answer is equivalent to, yeah, I'll actually use this as another example here in a second, but we'll just write true and false here. See out. Something like that. So I'll just have an initial print statement that says the number 0, the number 1, the number 2, the number 3, and I'll just end it at is, but I won't kick it down a line. Then I'll store my result of whatever isPrime returns inside of this variable. I'll remember the result, and then I'll ask a question about it. If the answer was true, if isPrime returned a true, then I'll output the word prime and kick it down the line. Else I'll output the word not, or the phrase not prime, and kick it down the line. Now you get a bunch of not primes because we're asking a question. We're interpreting the result of calling this function. I'm getting the result, and then I'm asking a question about the result and outputting text that is meaningful based on that. Yeah, keep going. Oh yeah, I mean, I don't have to do this. I mean, this is just me giving a different flavor output. Yeah, I could just have a whole bunch of primes, not primes like that. Yeah, because each one of these lines, I mean, this is just what I want my program to do. Remember, the job of a programming language is to allow us to tell this dude what to do. So if I want him to print some extra crap, I can tell him to print some extra crap. If I don't make him do it. Yeah. You could. But so he's asking this, can I change this to if answer is equal to 1? The answer is yes, but that is dangerous. Because remember, we talked about that officially in the language definition, false is 0, true is not 0. This will work out because in pretty much every example I've seen, true is always represented as a 1. But by definition, it doesn't have to be. But if, remember the syntax for an if statement, requires a Boolean expression. What's a Boolean expression? Any expression that boils down to a single value of true or false. So I actually could have just said, if answer. What's answer? Answer is the value that came out of isPrime. isPrime returns a Boolean. Does that mean answer in and of itself is a Boolean expression? Yeah, it's a single value of true or false. So if I say if answer is equal to true like this, and answer happens to be true, I'm really asking that question. Is true equivalent to true? It's redundant. It might make you feel better, and it's okay to write it that way if that just makes you feel better saying, hey, is this value the same as this value? Just because you could write it in a more simplified way, that's okay. You're not pressing anyone if you make that leap. Do it in whatever way makes the most sense to you. Go ahead. Yeah. You absolutely could. So he's saying, hey, rather than stored in a variable, couldn't I cut out the variable itself? Because I don't need to remember it. I'm not going to use it again, right? And then just say, hey, if this guy boils down to true, do this. Otherwise, it must have boiled down to false. So do this. This will be correct, but what we have removed the ability to do, which we're not doing now, so it's fine, is I never stored the answer that just came out of isPrime. So since I didn't remember it, I won't be able to use it again a second time, which is okay here. We'll get the same result. Go ahead.
Your question is, right now you're saying if else, was it in the itself, if it meets the condition, you think otherwise is wrong with it.
Right, because I don't have an else to this.
The else would be
Where?
I'm thinking if the number is 0 or 1.
Oh, this guy?
Yeah.
Well, oh, okay. I see what you're saying.
Yeah.
So it's an either or thing, and it's for a good reason. He's saying, well, why didn't I write this stuff inside of an else? This will give you the equivalent result, but here's the punchline. Here's the why. All right. So this will work. This will give you the equivalent result. But let me actually ask the class first. Why do I not need the else? Why does this work correctly without the else? Do you want to take a stab at it?
Because you're returning false up there.
Okay. Tell me about it.
You're returning, if it's 0 or 1, you're returning up to that program anyway. So, and if the number is anything but 1, or 0 or 1, then it's skipping that line altogether.
I'm only still alive here.
Yeah.
If I didn't die inside of the if statement above.
Yeah, I did it.
Since return makes a function immediately end, when I ask this question, if I get inside this if statement, this function just ended. The only way I even get to this line is if I survived that landmine above. That doesn't mean don't use an else. If you're more comfortable with the else, that's fine, because then you are more explicitly saying, if this is true, do this, else do something else. Nothing wrong with it. But you don't actually have to do that because of how fall through logic works. Only way I get to this line is if I did not hit this line. And then I want to do this stuff anyways. So it's not really an otherwise to this. It's a, hey, this is what I want to do if I'm here. All right, any other questions? Okay. And then what your output is kind of up to you. I mean, you can have a formatted output like this to, say prime and not prime. Really, your output for something like this is just to determine, to kind of test your code. Did it work or not work? Right? So if you just want to have a bunch of zeros and ones and that makes you feel like you tested it sufficiently, that's good. If you want to interpret your result in an if statement like that, that's fine too. The results that print to the screen in this case are not really what's important. It's, are you getting the correct result from your function? Go ahead. Yours prints true or returns true? Okay, well, you said it didn't have a return true. Oh, okay, so you do this. You never actually have it return true. Okay. Yeah, so you're getting something like this. So then what does that tell you? It tells you that the default value of a function that returns a Boolean must be a 1. Yeah. So let's call it accidentally it worked. Yeah, you should, because he said he went through all these things and he didn't ever hit a example where it broke. He just naturally ended the function, and it must just be that a Boolean function that naturally ends boils down to true.
So you could put up top there, who is prime is true, right? And then that way then.
Well, what are you talking about? Where do you want me to put it?
Right there where you're.
Okay.
Down a little bit. Yeah. So if you put is prime is equal to true, and then you have all the falses in there. So that would get rid that would.
I think what you're wanting to say is this. Call this answer equals true.
Yeah.
And then in here, rather than returning, you want to set answer equal to these.
Yeah.
You want to set answer equal to this. And down here, you're just going to return whatever answer is.
Yeah.
So answer started off at true unless I could disprove it.
Yeah.
And because I never switch it back to true. Once I hit false, I never switch it back. So in the end, I'm returning answer, whatever value it holds. This will work, but what's the problem with this? What are weaknesses with this? Go ahead. Yeah. So even if I find out that it was evenly divisible by 3, I still got to check the rest of the numbers, only to know that I already found one that broke it.
Well, for I is equal to and then I count or a number and then divide that by 2.
You want to do this divided by 2?
Yeah.
Still the same problem, just half the problem. Yeah, because he's saying, hey, I only actually mathematically need to go through half the numbers. Because once I get to the other half of the numbers, it's going to fail. That's fine, but you still have that doesn't fix the current problem because you're still wasting your time potentially with half the values. Now, you could hack this and say, well, if I'm going to change the answer to false here, I can go ahead and set I equal to the number, which will then cause the next loop through 4 to fail this, right? So I'm kind of short circuiting my for loop and saying, look, I don't want to go through again. So I'm going to go ahead and artificially modify the value of I. So I break out the next time. We also have a keyword called break. And break fits into the same category of return. Let's add this to our notes. So we have a keyword here called break. Return makes a function immediately end and optionally can return a value. Break breaks us out of the current, call it closest loop. Note, this does not end a function. It just gets us out of a loop without us having to manipulate a variable which would cause the loop to end on the next pass. All right, so break is the way to get out of a loop. Okay, now again, so the exercise that we're going through right now, and this is good because we're messing around with the results and kind of saying, oh, well, what if I did this? What if I did this? So, and we're seeing we can get the correct result multiple ways. That's a good thing. Okay, but don't get too far into the weeds with this. I mean, what I showed initially, let's say is good enough. All right, this is just showing you how elastic this could be. You're not chasing the right answer. Okay, you're chasing something that functionally gives you the correct output. But the way you get there is different things, and that's why you could be creative as a programmer. And that probably, actually, it might even make you feel worse. Like, look, I spent 5 hours on this, and you're telling me there was 20 different right answers, and I didn't get any of them. Par for the course. You're going to spend time on this for a while, and you're probably always going to spend time on it, but you'll end up just getting better and better because the stuff you did 2 weeks ago will seem easy. Go ahead.
So I'm doing a replicate.
Yep.
And no matter what I do, or not no matter what I do, but I can't like compare on the line like the if statement.
Can you just paste it in the Slack real quick?
Sure.
Or give me, yeah, you can paste even your, well, yeah, paste your code in the Slack real quick. Because debugging is a good tool too.
Yeah.
Sure, yeah, go ahead.
So I did basically my question was answered, but at the same time, is in the not.
That's because you did an endl here. Right?
Yep.
Yeah, endl kicks it down the line. Yep. Sure. Oh, you sent it private message.
Yeah.
Actually, I wonder, what is this? Does this fix it? Nailed it. That's a handy button. Beautify button. Format this stuff. All right, so let's walk through this. So you prototyped your method up here. You have your main, fine, for loop going through 2 to 100. That's fine. You're outputting the number, colon, calling isPrime, passing it X, calling end L. Here's your function. Takes the number, x is 2, x is less than number, x plus plus. You have a semicolon here at the end of the slide. So you're never getting to your logic in here as part of the for loop. Common mistake.
Yeah, I don't know why there's.
No, I mean, I'm saying it's a common mistake. And the reason I know to look for those is because I spent hours looking for one of those. I spent hours debugging a program one time, not finding that, and felt pretty stupid at the end. But I was trained now to look for, look for those things at the end of the line. And I really want that. And I'm not even kidding. I mean, that happened. And I spent hours and hours staring at it and ended up having to take it to the teacher. It was Dr. David Salt. He works for Hewlett Packard now. It was my teacher. Took it to him. I was like, I don't know why this is working. It's got to be the compiler. It's always your code. I promise you, it's always your code. I wrote the same code that you wrote. It's word for word, no difference. But yeah, so I probably spent 4 or 5 hours staring at that code. It was a little bit more complex program, but still, I went over it heavily, never saw it, and now I've trained myself to look for those little mistakes. All right, anything else before we keep trucking? All right, so what I'll do here is I'll go ahead and give you this current state of the code. Let me make sure this does what I want it to do, because I know I was zigging and zagging a couple of things. Yeah. Keeping in mind that I just happen to be writing some output that is verbosely spitting out whether things are prime or not prime, because I'm asking a question about the result. You didn't have to do that. If you just wanted to have it go give you a bunch of zeros and ones for testing it, that's fine. This is really what you want to focus on. That's the logic that we wrote. Today's algorithm is what we're looking at right there. How we tested it is what's above. And that's actually a pretty important distinction, which came back to one of his early questions. This is me defining a function. I happen to be calling that function right there, but I never have to call it if I don't want to. This is an untapped resource until I actually call upon it. All right. So there is a distinct difference between you defining a function, which we define generically based on the input. This guy takes in some integer. I don't know what the value of the number is going to be. It's just going to be an integer of some kind. So that means my logic in here has to be based on the logic or based on whatever this number is. And I actually do want to fix this up a little bit because the current thing is pretty inefficient. So we'll go back to return false here. I'll put a little comment. It says handle the special case of 0 and 1. Handle all numbers greater than 1 to check for prime. If I hit even 1 that breaks the rules, return false. Otherwise, return true. So if you're taking a couple of rules of thumb today, if you've advertised you're going to return a value, return a value. This guy is guaranteed to return a value. I am guaranteed to either get inside there, get inside here, or if I'm still kicking, once I got through all those things, I'll return true there at the very end. This code is guaranteed to return a Boolean eventually, which is good because I promised that I would. All right. Code to detect primes and display whether the numbers between 0 and 19, that is what I currently have, right, are prime or not. All right, so there's an example of the code you could have had for your homework. Right there, that's the most important part. I don't really care if you handled the special case. Wasn't a big deal, but I don't know that we're necessarily running around thinking about the couple of special cases for primality of numbers and things like that. As long as you cover most of the numbers and you have this algorithm of checking stuff for evenly divisible in the middle, that gives you some good practice. Yeah.
For the homework, we had to put it to 0 to 100 and
Display, did I say only the prime numbers to the screen? Okay, thank you. So you're supposed to do 0 to 100. Let's go including 100. So we'll say, and we're only supposed to show the prime numbers. Okay. So this is going to go through all the numbers between 0 and 100, including the 100. Each time through, I'll ask, is the current number I'm looking at prime? If it is, display the number. So this will show us only the prime numbers between 0 and 100. And we didn't really change any of our primality logic there. We just said, hey, I have this tool that knows how to detect primes. I'm just going to use it to only output the ones that actually came back true from that dude. Okay, let's see. Let's look at strings. Yeah, that's a good next guy. All right. All right, and we're going to keep practicing with that logic. So we're going to constantly have these little puzzles we're going to work it out, but we're going to keep changing the types we're working with and that kind of stuff. So we're going to talk about the string data type. Oh. So strings are things that start with an opening double quote, have some number of characters, like hello world is a string. Okay. So these are data types that we'd like to be able to use. Now, strings get a little bit complicated when it comes to an older language like C and C++. And in here, we're not going to dive too much into some of the underlying things, but I will talk about it at the high level. Okay. So in C and C++, we actually have at least 3 vintages of strings. You have the original string, which is what I have written right here. So the original string is actually stored in something called a char pointer. And this guy would look like this, string S, hello world. A more recent, we'll actually just look at 2. We'll look at the old way and the newest way, which is what we're going to use, which is basically identical how all the other languages use strings. Okay. The new way would be this: string S is equal to hello world. All right. Now we might say that, okay, well, that's not that big a deal. We haven't really talked about pointers in here too much, and there's a good reason for that. We will eventually, but for right now, that's what this guy is. It's a memory address. When we talk about arrays, this will make sense here. So the next week or so is going to be pretty interesting, getting into some memory address stuff. But in any case, old style strings are primitive types, which require an external library to operate on them. Now, just to kind of talk about what I mean by that is, if we just look at a string like hello world and we say, what are some things that I might want to do to strings? I might be interested in how many characters are in this string, for example. Okay. So old style strings, we would need to use an external library that knew how to deal with strings. So we had a function called string length s. And this guy would have produced for us, what we have, 5, 10, 11. That would have produced for us an 11. That gives me the length of that string length. Okay. I might have also been interested in the value at bucket 2 of that string. This is bucket 0, bucket 1, bucket 2, bucket 3, 4. So it's a 0 indexed thing. So I would get at that by saying s at bucket 2, like that. And that would give me the value that lives at bucket 2. So this would produce for me 0, 1, 2, and L. That first L. Newer style. New style strings are object types. And we haven't dealt with object-oriented programming yet, but we did talk about the object-oriented, the telephone versus the procedural telephone, pile of wires versus the thing that looks like a phone. All right. Objects can hold a value, but they can also potentially do more. So our newer style strings, they have abilities in and of themselves. Let me just throw a slide in here. Primitive types versus object types. Primitive types can only hold a value. So our primitive types, that's the byte short, int long, char, float double, Boolean, bool, I guess in C. Those are the types that are built into the language, as well as old style strings that we're not gonna use in here. I'm just introducing them for a foundation type thing. All right. So these types can only hold a value. That's all they can do. Object types can potentially hold a value or more than one value. They don't have to though, and can potentially do more, like have functions that operate on them. All right. So we would say object type values are more powerful type values, but probably come at some other cost. We're not going to worry too much about that other cost for now, but we'll say these are a more evolved type of variable. So since this new style string is an object type, these guys have functions built in for doing things with strings. So for instance, I can say s.length, and that will give me the 11. I can ask a string to report to me what his length is, rather than having to ask this third party to take a string in as a parameter and spit back out how many characters are in that string. We would say this seems better. Now, this is interesting how this works. But for right now, and I might swing back on this at some point, but for right now, I want you to kind of just put this as the history lesson in your head somewhere. It is important, but I don't want to get too far into the memory weeds yet. We're not going to be comfortable with that at this point, especially when we're going to end up doing this. Okay. But I promise this is important, and we're actually going to be stumbling onto it a little bit next week when we start talking about arrays. All right. But for right now, we're going to say, hey, you know what, it is the year 2021, and languages have come a long way. And just because we're purposely using an older language like C++ to be a little bit more revealing about some of the details that are happening under the hood, we don't necessarily need to punish ourselves at this point. Make some sense? So we're going to use this newer style string, which is part of namespace standards, so kind of lives in the same place as cout. So let's go into our code here. So I'm going to include string. I'm going to go ahead and get rid of, I already put this stuff into Slack. All right, so I'm including another library here. Oh, I did have somebody ask the question after last class just about the standard io.h. I know I mentioned it at some point. This is what they put in there as your default IO. So old style C input output lives in standard input output, standard IO. We're not using any of that. We've been using cout, so you actually don't need this library here. But that's what lives in there, is older style input output stuff. Printf, scanf for the functions from that. And they actually are still useful. Just because they're older doesn't mean they're useless. But again, we only want to reveal some of the details for us right now because our real focus is in practicing with these little algorithm puzzles. And we want to appreciate the weeds, but don't get too far into them at this exact moment. Okay, so I've brought in one additional library here called string. Okay, and it's because C++ has old style strings built into it, but I want to use new style strings. So that means I have to bring in this library that is a much newer library than the language C++, so that my code will know how to use that. Just so happens that dude lives in the standard namespace. Let me just confirm that. I don't want to lie to you. Should yell at me about S here. Yeah, it does. Yeah, so it lives in the standard namespace just like the IO stream stuff does. All right. So I define my string just like a normal variable, right? We have the type followed by the variable name equals the value. So now we have a new kind of value that we know how to hold. We know how to hold strings, collections of characters is what a string is. Okay. Well, I mean, it's collection of characters. So that could be numbers, it could be question marks, anything that's on the keyboard. So this is anything that's in the ASCII character set. All right. And I've shown you, we have a function here for printing out the, for getting the length of a string. So that means I can go through a string. So I'm going to have a loop that goes through s.length number of times, starting at bucket 0, because that's the first legal bucket of my string. If my string has a length of 11, legal positions in that string are 0 to 10. That's where those buckets live. And we'll talk about why they're 0 indexed when we talk about arrays. All right. So I'm taking I on a voyage between 0 and, in this case, 10. Each time through, I'm going to say, I want to print something out. What am I going to print out? I want to print out the character that lives at position I in that string. And then I want to kick it down the line. So we're going to get HELLO space WORLD. So there's my length. I printed out 11. And then here's me looping through every character in that string. Go ahead. Lowercase. Yep, it is case sensitive. It's possible they have a macro that will make it work with a capital, but correctly it's a lowercase. Yeah, it yells at it. All right, and again, pretty much all programming languages are case sensitive. So there is a difference between string with a lowercase s and string with an uppercase s, and in here, uppercase s doesn't exist. Okay. So now let's talk about another skill called concatenation. So concatenation is the act of building up strings by gluing parts of the string together. The operator we use is the plus sign. So when we're using the plus sign in conjunction with strings, it's treated as the concatenation operator. When we're doing it in the context of numbers, it's not using addition. So for example, hello concatenated with world would produce for us the string hello world. It glues those guys together. So if I come back out here and I say string s2 is equal to hello concatenated with world, and then I print out s2. Use the plus sign with those. Oh, I don't want to have to. Let me just make sure this is the fix before I screwed up the interpreter. Yeah, that is the fix. So what I'm having to do here, this goes back to what I was talking about before, where C++ supports old style strings and new style strings, but the default is the old style strings. So if I just look at my original values here, double quote, hello, double quote, C++ has no way of knowing whether I'm talking about old style strings or new style strings. So the default is to treat these guys as old style strings. For old style strings, we couldn't use the plus sign for concatenation. You actually had a function called strcat, string cat, that allowed you to glue two strings together. So if I say strcat and I passed it these two guys, I think this guy lives inside there. I might have to bring in string.h. Yeah, it's not declared in the scope, so it's probably inside of string.h. All right, we're only going to go down that path so far. Okay, I don't want to confuse the issue here. Unimportant for us right now. I'll give you a more convenient way of doing this for concatenation. But what I've told you so far is accurate. And we just showed it's accurate by making sure we emphasize to the interpreter, to the compiler, that these are new style strings. Okay. Now for the homework, and I won't have you do concatenation for the homework. write a function called print reverse that takes a string as a parameter and displays to the screen the contents of that string in reverse order. For example, if I called print reverse on hello, it should display to the screen that. Of course, you try to make sense. You can either put it all on one line, or you can put it on multiple lines, doesn't matter. I want you to practice with working with strings now, writing loops that go through the string in the right way to ultimately get the values of the string in reverse order. All right. Submit a link to the code and the self-assessment. Questions, comments, concerns, bribes? Go ahead. S is a variable in here that is holding a string type. Dot length returns the number of characters in that string. It's a function that strings own. Yep, that a string has. So when you write your function, you'll take a string in as a parameter. You'll be able to ask that string, what is your length? You'll be able to say, let's assume you name your parameter my string. You could say my string dot length, and that'll tell you the number of characters of whatever string was passed in.